Hello everyone, I am Kalyan Dhokte and welcome to Conference 42, DevSecOps 2022. I am from Cognizant Technology Solution. Thanks for joining my session. I am going to talk about a role of SRE in DevSecOps. Before starting my quick introduction, I am practice lead and responsible to serve customer for building highly reliable, resilient enterprise systems by implementing modern digital engineering techniques like SRE and DevSecOps. Let's deep dive into the session. Uh, First, we will understand relationship between DevSecOps and SRE. If I take a minute to understand about DevSecOps, it is integrating security as a part of your pipeline. As you are aware, in DevOps, we focuses on continuous integration, continuous delivery, and continuous deployment. So you make design to deployment all the phases automated. And now DevSecOps integrates security as a part of entire life cycle. So benefit of DevSecOps to detect security much early in life cycle. What is DevSecOps to do with SRE? Let's understand that. As you know, SRE focuses on reliability and resiliency of the system. It also helps to engineer highly performant, scalable, fault-tolerant applications and help customer to build always-on business. So reliability is also mean that you are protecting your systems from unauthorized attacks and you are preventing vulnerabilities, threats, and also protecting customer data and finally managing and maintaining privacy of entire ecosystem. So for all practical purposes, SRE implements DevSecOps principles and security practices. Let's understand what are the different principles DevOps and SRE implements. So eliminate silos and also eliminating toil is one of the important principle. Let's understand shared responsibility of security and embed security in development teams. Accept failure as normal, gradual changes, automate everything and measure everything. So it is important to reduce cost of failure by incremental changes and doing the blameless postmortem, basically adopting security best practices and creating uniform security posture. So automation also going to help to improve reliability and automating security monitoring and testing is one of the important aspect of DevSecOps. So SRE helps to enforce robust monitoring of reliability and security throughout. Also making sure SLO, SLI, and actionable alerts are getting triggered for any such. So our systems are uh, becoming so evolved beyond human ability and to mentally uh, understand that model and their behavior is very difficult. So why these modern cloud technologies are challenging? So modern microservice based architecture, cloud native architecture increases speed of scale along with complexity with improved cost efficiency, accelerated innovation, faster time to market, and the ability to scale applications on demand. So in this case, with CI/CD, DevOps, and cloud native microservice architecture, we are building systems so large and changing so often. Continuously, we are changing based on innovations and new features to deploy a very fast pace to production. And it's very difficult and very hard to track what is going on in the system. For example, Salesforce CRM, okay, is having hundred thousands of microservices, which is very difficult to track all these things and which increases the complexity. So as you increase more features, adding more features, the complexity also going to increase. So does this complexity coming from? So we are creating and deploying new features with continuous delivery, cloud native serverless architecture, API and microservices, service mesh, release engine. All those are very good to making sure you are continuously innovating and continuously deploying new features. But that also increases the complexity. And then when it uh, goes in a month, and then again it's in the end of the year, you will see very difficult to manage and maintain that entire complexity because complexity is continuously also increasing as you are upgrading Kubernetes systems, upgrading cloud services. There are some outages you are fixing continuous. any related to security related issues. If there are certain misconfigurations, you are refactoring code, moving lot many applications to cloud native and serverless kind of architecture, changing deployment tools as well. So all those factors going to increase the complexity. If you want to simplify the complex system, you have to change it. But in order to changing systems for simplification, you will be adding additional complexity. And complexity is how you. It is not easy to simplify, and it is very difficult to understand. But complexity is more about navigating it. So how you will navigate the complexity? Let's understand that. So security is a context-dependent discipline, and then by applying all these DevSecOps and SRE practices, you could able to navigate the complexity very easily. So, so flexibility to change the system rapidly, and then applying security context to system changes. So you need to understand security is a stateful kind of nature. Okay, it's we can see there is a clear conundrum as developers constantly implements new features and move towards customer value rapidly. And in this case, security will not move on the same curve. And then there is a constantly you have to verify security and reliability is implemented as per design. So in this case, continuous security and reliability has to be embedded, and then you need to continuously check and verify that security with the security first mindset and reliability first mindset. That's very important. You need to infuse all those things into development, deliveries, and in production. So SRE basically helping in securing the infrastructure applications when you deploy into production. And then it will help to basically tracking the availability, SLO tracking, error budget, all those aspects, which includes automated security monitoring as well. So in this case, you need to combine framework of DevSecOps and SRE and continuous security to assess for such complex distributed microservice architecture. And because a lot of bad actors are continuously chasing such complex enterprises for various attacks, and the race for to defend against attackers must be accelerated. So compared to functional failures, the reliability and security failures frequently impact entire enterprise systems and also impact the brand value. Hence, special attention is required for the security and reliability. So there are some trade-offs as well between reliability and security. While redundancy is going to increase the reliability, it also increases the attack surface. So reliability and security trade-offs with respect to incident management. So when you want to improve MTTR and then reliability incidents basically benefits with the verbose logging, while those logs would be a again target for those attackers. So you need to be very careful while making sure basically striking the balance between security and reliability. Let's understand what are the common symptoms for failing the DevSecOps and SRE models. So one important thing is avoidance and blame. This is one of the symptoms. A lot of developers and then teams are saying the security team is blamed for slowing down the projects. The pipeline entirely getting slowed down because of the security reviews, and project teams are frequently sidestep that try to avoid the security. Slow and ineffective security reviews of new applications take weeks and then also produce little actionable information. Bad user experience. Basically, the user experience for authentication and authorizations are sometimes very much inconsistent. And then there are gaps in risk profile as well. So large parts of your technology portfolio have undiscovered security and vulnerability. So, and then all these things increasing the complexity, and then the complexity is becoming very unmanageable. So, your vulnerability list is very large and complex, and it is growing rapidly when you uh, move towards the or shifting more application to the production. So, how can I diagnose this? The diagnosis basically need to understand why these symptoms are, and then basically it is misaligned teams and reinventing to security and then basically reliability wheels. Security and reliability involved very late in the game, and many times there are a lot of lack of automation. So for this, remediation is definitely embed security, security first mindset, and then also reliability in development teams. Embed reliability in development teams. So create security and reliability standards and accelerate that, as well as automation of the securities scans and continuous security testing, observability, and resiliency. We need to understand what how we have to make DevSecOps is a kind of healthy operating model. Embed the SREs into dev teams to help implement security and reliability consideration early in the design and development phases. So let's understand what are the common practices for success of DevSecOps and SRE model. Enhancing DevSecOps operations has become the SRE's top priority in light of digital transformation and continuous escalation of cyber attacks. So all these aspects are very important to making DevSecOps and SRE models successful. Embed security in development, reliability driven development, automation, and full stack observability. So that's going to enhance DevSecOps operations and will be success of the DevSecOps and SRE models. So moving into the operation service model, DevSecOps, with you need to embed reliability and security stack. So I personally believe value stream management to play a big role from planning to operations along with security and not just a CI/CD pipeline in digital transformation journey. So basically, value stream is a business practice that helps to identify areas of improvements. Okay, so in a process to make operations more efficient, you need to drive the business value. So value stream management will will help in security governance, automation, security dashboard, analytics, policy as a code, and pipelines. So from planning design phase to monitor phase, the security will be embedded right from the threat modeling. You need to implement SAS, SAST, DAST, as well as chaos security experiments. So security policy compliance, then you need to continuously schedule some of the audits, fuzzy test, WAF penetration testing, automated security monitoring. Right from the plan to design, all till entire operation, pre-production as well as production. How the security will be implemented in the production pipeline, and then as well as the reliability is equally important, which help to making DevSecOps production pipeline more secure and more reliable. So combining value stream management with the implementation and expansion of DevSecOps and SRE practices is becoming the best of breed approach to optimize every stage of deployment, development, and security, embedding security end to end. By having everything in a single pipeline with optimized value streams and checks and controls for vulnerability and any kind of misconfiguration, you are going to eliminate any time consuming manual reviews uh, and then help to accelerate the production pipeline. So here you need to understand if there are certain shift left and as well as you are moving some application to cloud and existing there are some existing process and tools. You need to understand what are those existing process with respect to people, what kind of skills are there, what kind of culture, what are the processes available, are they implementing policy as a code, what are the different security practices, and then what is the technology. You can't just uh, start from the scratch. You can basically learn and document the existing process, adopt and then adopt and optimize, use those existing uh, processes and technology and skill set, and then implement DevSecOps pipeline. So there are certain automated and advanced techniques of DevSecOps and SRE, basically to automate all your deployment pipeline. So SREs have also devoted a lot of their time in attention to shifting right of basically for automating security monitoring in production and then giving continuous feedback and then based on security monitoring data back to developers. So you need to help and then support basically automating with this advanced technique to developers. So there are security gates that you can automate to stop workflow from slowing down and then basically making up monitoring and monitoring analytics into the pipeline. Then automate close verification checks into the DevSecOps framework, reliability driven development, code profiling, tool integration. All these are very important techniques you can automate. And there are certain AI and ML techniques for threat analysis. So advanced DevSecOps framework take advantage of AI and machine learning techniques to basically to streamline and simplify, speed up the complex DevSecOps stacks. There are two examples I would give. One is basically collecting and analyzing software while users are logging uh, into the system, and then those logging information will identify which aspect of software with the bad actors are attempting to target. So this information will give to the AI ML algorithm, and then it can suggest different code alteration and adds or any architecture changes is required to proactively identify code vulnerability. From a testing perspective, code changes can be run through finely tuned machine learning tools to identify how a particular change might affect other aspect of the application. So these are the examples where you can have AI backed threat analysis, and then you have to making sure the chaos engineering with respect to security experiments can be also integrated, which will give the automated DevSecOps pipeline with the tools like Gremlin, ChaosLink, CloudStrike can be used. So we'll provide more details in the case study about the ChaosLink. And then in operation side, you need to making sure automated security monitoring and analytics will be implemented, SLO tracking for reliability gates and operation excellence dashboards, auto auditing and compliance tools that streamlines basically a lot of compliance related reporting. And then deployment of these scripts validation, basically there are certain security context and flags you need to add while deploying any pods in the Kubernetes. And then and security policy framework will continuously monitor and assess that security flags. So overall, these advanced techniques for automation of DevSecOps and SRE will provide a lot of cost savings potential. So DevSecOps and basically SRE automation when you complete or which will help to lower likelihood of any catastrophic cybersecurity incidents, and the reduction in number of operational staff, which basically improve your MTTR and then reduce a lot of P1 tickets. So let's understand what is SRE role in DevSecOps according to team topology. So effective software teams are very essential for any organization to deliver value continuously and sustainably. So, but how do you build the best team for the organizations and your specific goals with respect to culture, what kind of skill set you have, what is the leadership, and then all development operation team. So there is a bridge between dev and ops that SR is going to help bridging the gaps between operation and development team. So SRE will help in reliability and resiliency kind of uh, features that has to be prioritized, and then it will help and then basically automate reliability engineering, security observability, security feedback, constantly giving implementing golden signals. So SRE is going to help into bridging the gap between operations and development team. The role of SRE is to collaborate, engage in value-added activities, and create results that contribute to measurable reliability improvements. So we understand what are the different tasks with respect to uh, SRE role in DevSecOps. What are the backlogs? The initial adjustment to DevSecOps model requires a change in mindset for developers and SREs, but building in vulnerability detection ahead of app deployment ultimately lowered their stress around the security. So SRE tasks in different phases for improving reliability, resiliency, and the security. So basically, with respect to security, you need to secure the build pipeline, secure entire deployment, and also runtime protection. So security side of it is mainly uh, enabling security code scanning, security policy for the whenever the pods are running in AKS Kubernetes cluster, configure and validate deployment scripts for security context. So overall reliability and dependability is consist of 7 attributes, and the security is combination of confidentiality, integrity, and availability. So confidentiality is mainly ensuring that the information is inaccessible to unauthorized people. commonly enforced through your encryption, IDs, and password, and even with the two-factor authentication. So is mainly safeguarding information and system from being modified by unauthorized people. And of course, availability is ensuring that unauthorized people have access to the information when needed. So, and then safety, resiliency, and maintainability is also is will basically contributing to overall dependability of the system. So these are the some of the tasks and backlogs you need to continuously implement during the every phases, right from the build, deployment, and operations, with respect to specific areas of reliability, resiliency, and security. So next is yeah, sorry. So plan to and then develop the threat modeling uh, from the all the phases. So building this is one of the case study where uh, building security and reliability in DevSecOps pipeline. So right from the plan and develop, you start with the threat modeling. So there are certain threat modeling tools you can implement, and then these modeling tools will help to identify the impact on the design, various design components. IDE security plugins will start on the immediate code scanning, pre-commit hooks, and then the secure coding standards. Then commit to code. When you commit the code into any repository, you need to understand what is the secure repository are you implementing or not. Then there are static code analysis, um, then dynamic security unit functional test, dynamic security testing as well in the build and test phases, dependency management, secure entire your secure pipeline. So infrastructure scanning, cloud configuration, validation, all those processes are important in right from the plan and develop to operate phase. This is the security model, ideal security model. Apart from that, in build and test, there are certain plugins created for this case study. Is basically YAML validator and security context schema. So you will have certain plugins in this case, which is the Azure pipeline. So we have to making sure while developing the developers are coding the YAML files, YAML scripts, they are adding the relevant security context and the security flags so that, for example, uh, uh, run as a non-root user, or you should not have access to root file system. Allow privilege uh, access should be false. So all those things, read only root file systems. All those flags need to be checked and validated while you are executing the Azure pipeline. So continuously checking that schema and then providing the report directly to the developers. That can be automated as well. And then there are, in a before going to the production, when you are moving your code into non-production environment and also the production environment, there are chaos engineering and security experiments can be conducted using uh, certain security experiment tools like Chaos Slinger and Gremlin, which will help to understand the complexity. And you need to basically navigate the complexity, and then any changes, any turbulence condition arises, you need to be prepared for that. Basically, giving the confidence to the developers and um, operation team. So, security vulnerability is one of the area you can simulate with the fault injection simulations for also for the reliability side of it. So from the when there are relatively easy and cost effective to resolve those issues, as a result, it greatly reduces the total cost of deployment. Okay, and then also the development because you are identifying those security issues early in the life cycle. Also, we need to design certain tools with non-security experts in mind and making threat modeling more easier for developers by providing clear guidance on creating and analyzing the threat model. Okay, now understand the some of these security policy can be enforced. Security center like Defender continuously discover new resources and are being deployed across your workloads. and assets, uh, whether they reconfigured according to security best practices or not, and then the tickets are flagged, and then you will get the priority list of all the recommendations. So this is basically enforcing security policy using security center. So it will understand to help you to know the posture, continuously assess and identify vulnerabilities, harden those resources and services with security benchmark, and detect and resolve threats to resources and services. So the major motivation for chaos engineering for with security experimentation is to gain confidence when systems are exposed to any real life scenario attacks, and that can be transmitted to any cloud platforms uh, with various APIs and then various attack surfaces. So there is an open source security experimentation tool like a Slinger and then CrowdStrike. So SRE engineers basically design security test scenario by assessing risk-based fault vulnerability assessment, and then create the various test scenario. So there are certain components. One is controller, which coordinates the chaos injection experience. Then manager, which receives the instruction to conduct attacks based on specified attack modes. Fault engine that will help to knowledge on about cloud compliance and best practices. Fault injector is responsible for implementing the security and fault against the target cloud assets. Chaos monitor is an important a component which will continuously monitors and the progress of attacks and early detect any effects due to fault injection, which will basically control the blast radius. A chaos analyzer analyzes the scores and generates the report. So possible recommendations to include for updating any security rules for security groups. If you are creating any energy rules that can be added or enhanced because of understanding the after the simulation recommendations. So and restriction of access as well as uh, making sure access control policies are intact. So all these are the important recommendations can be derived from uh, chaos engineering experiments. So various test category, there are spoofing of user identity and other entities, then tempering the S3 or RDS or Redshift kind of a data store, privacy breach or data leaks. There are misconfigured default security groups, uh, denial of service, destroy cloud services configurations and data store, and then elevation of privilege uh, to basically add some users and assets account to existing roles or groups with higher privileges, and then check if are you getting the security alerts or not. Basically, checking the security alerts is the important aspect to validate all those scenarios. Validating baseline security requirements, assign some public IP to your components and compromise with the internal resources, and then check the security center is validating and providing the alerts or not. So scenario are also there with respect to Class Slinger and CloudStrike. So one is scenario is misconfigured port change and S3 bucket permission changes. So you have list of NSG, and then you need to select those NSG that are tagged with the opt-in tag for chaos. Randomly select any NSG and apply random open or close action based on the port configuration. Chaos Slinger will help to apply those configuration changes, and then there is generator components which starts experimenting and performs port acquisition and change the port. And then you need to track the changes, verify events are triggered in security center alerts or not. So that is one of the scenario that you can test it. And then S3 bucket permission changes. You have to create one new user, get a list of all the buckets in the cloud with respect to AWS or Azure or GCP. So select random bucket from the set of buckets in the cloud and configure attack points using these chaos tools. Then simulate bucket unavailability by changing bucket ACL from allow to deny. And tool will apply the configured changes. Tool starts the security experiments, and you will get the real-time insights of the chaos engineering toolset for the experiments. And then you can monitor the AWS CloudWatch and verify events are triggered in security center or not. So, so there are two things. One is testing with the penetration testing and all those things, and also it is very important to making sure do you are creating automated dashboard and continuously monitoring the security and reliability. So apart from that, you have to create a customized SLO monitoring dashboards, use of automated root cause analysis. Without the automation, it is very difficult to uh, because a lot of data is getting created and then it is very difficult to making sure pinpointing any component and issues in the production system. So use of automated root cause analysis is going to use anomaly detection and suspect ranking. Automated machine learning is applied using the Python, scikit-learn and all those things. So these are the automated dashboard that you can create and then understand where is the anomaly, identify the anomaly and detect it uh, very far rapidly. So, uh, the summary here is uh, the cultural aspect of SRE to embed security along with reliability, implement SRE practices in DevSecOps like security chaos engineering, improve organization defense, and zero trust network. And then making sure reliability and security integrated into design and deployment process. You have to making sure eliminate reliability, security related bottlenecks with continuous delivery in a production pipeline and bridging the gaps with security practices while ensuring quick and safe deliverables. Eliminate all the siloed team and with increase the collaboration and shared security responsibility and reliability driven development. These are the aspect takeaway from this session. Hope you enjoyed this session. And then I will leave you to two quotes. So SRE work is like being a part of the world's most intense pit crew. We change the tires of a race as it's going 100 miles per hour. So that's a quote from Andrew from SRE at Google. And then another quote is you need to continuously evolve and change. What's dangerous is not to evolve. That's a quote from Jeff Bezos. And then it's very important to understand and then continuously evolve with the new changes. So thank you very much. Hope you enjoyed this session. And if any questions, please reach out to me either on LinkedIn, Twitter, and Kdokte, Kdokte at 9987 on Discord. Thank you very much. Bye.